Hi class, in this lecture I would like to talk about some variations from the transportation problem because in theory actually for the network flow model you can calculate the mathematical model very fast and get some decision variable theoretically. Transportation problem is one of them. So if you can try to analyze some problem and transform this kind of problem into the transportation problem or network flow problem, then you can easily get the optimal solution through the mathematical model. Okay. So I will give you some variation of the transportation problem and how to apply the problem and use transportation model to solve it. Before that, I would like to talk about within the transportation problem, if some route is forbidden, then how can we deal with that? Okay. So for the transportation problem, for example, we have 3 plants and 4 distribution center. Okay, and then now there is no route between plant 1 and the second distribution center. Okay, then what is our strategy to doing this? A very simple one is we something like give a very large penalty if we choose this route. So we can change the unit cost a very large number instead of a very small number, and you will see all of the unit cost compared to 10 power 6 is relatively small. Then it seems like you have a very, if you choose this cell, choose this route, then you will get very large penalty, and because we want to minimize the cost, so this route will not be chosen. Okay, this is the first way to do that. And also the other strategy, maybe you can just add one more constraint such that x12 equal to 0, put into the transportation mathematical model. But if we edit something like this, actually we add some complexity into the model. Of course, for this very small model, it's okay if you added just 1 or 2 constraints. Okay, so either way, you can use different strategy to solve. Some route is forbidden. Okay. Okay, now I'll give you some application that can transfer the problem into the transportation problem. Okay, the description of this production planning is for a specific TV product in a factory. The demand from January to April are 2,000 units in January, 1,500 units in February, and 1,900 units in March. Okay. Also, I think here is typo because we only have 3 months, right? It's March. Okay, from January to March. Sorry for the typo. The production capacity every month is 1,700 units in the normal shift of the daytime and 500 units in the nighttime. Unit cost for daytime production is 40. And the unit cost of the nighttime production is $60. Try to use the transportation model concept to solve the problem. Okay. So basically, we can transfer our description into the table as well. So the start point is the daytime in January, nighttime in January, and daytime in February, and nighttime in February, daytime in March, and nighttime in March. Okay, so basically the start point, we can set this could be 1, 2, 3, 4, 5, 6, right? And for the destination point is the demand for January, demand for February, and the demand for March. And if you consider the supply, you will see here and here are not the same, and difference is 100. So we added the pseudo and, okay, and cost with 0 here. And also beware of something like if we have a production in February, right? In February, then we get a penalty here, which means your production in the February cannot go to January, of course, right? Because January is ahead of February and March, right? So we can see here have a large penalty, and the symbol normally will use the M. In reality, or in the games model, normally we will put is a very big number like 10 power 6 or 10 power 8 and something, right? And also, if you cannot, for example, if you put production in January, but you cannot sell in the January, then it will have incur the holding cost $5. Okay, so basically you can change the production planning problem into the transportation problem from start point to end point. Okay, so this is the first case. And we can use the mathematical model, right? So the Cij here is the unit cost. And it doesn't matter if you have a high penalty, because the unit cost is a very high penalty. Okay, so the S here basically is this number, right? And the D is this number, right? So here, this number are C, right? So all of the parameter we have, then we can solve the problem. Okay, so here is Xij, here is X11, X21, X31, X41, X51, and X61, right? So here is X12, X13, and X14. Okay, so after you solve this mathematical model, then you can get the solution. And also, if the problem structure is like this, you also can use the northwest corner method or minimum cost method as well. Okay. Okay, so this is the kind of west corner method. So for advertisement problem, also can change the advertisement problem into transportation problem. Okay, let's see the description of this problem. The purpose of advertisement is to use different media for promoting different target market. The start point would be television, newspaper, radio, and poster. Each media has each target number of population, which should represent the supply of the media. The endpoint is different target by age. The age target population represents demand. The unit cost of median for different age target is different. The following table shows the detailed structure of the problem. The objective is to minimize the cost. Okay, so we will something like that. We have for 4 different media, which is the start point for the transportation, right? So we have the newspaper, radio, TV, and poster. And for each medium has its need to that different population in different age to see the newspaper, radio, TV, and poster. So we divided age into different population group, which is the end for the transportation problem. Okay, so the age between 17 to 24 and 25 to 45, 46 to 65, and above 65. Okay, and also for each newspaper, there's target population is here, which means SI here. Here is DI. Okay, so here is CIJ, right? So we can transfer this advertisement problem into the transportation problem. Of course, now maybe the newspaper or even radio, TV, or poster are not so effective for the advertisement media, right? Maybe TV is okay, but for traditional media, maybe not so effective. So nowadays, maybe you will consider through the YouTube, Instagram, right? FB, Facebook, or you can use different like TikTok, maybe, I don't know. Okay, so this kind of advertisement, you can also have some target population in different ages. So you can modify a little bit and become the new advertisement problem. So this is also an idea for you for your class project at the end of this semester. Okay. So I leave this problem for you for practicing, but I still like read the description for supplier selection. One company produces a product which requires 3 materials A, B, and C. There are 4 suppliers, A, B, C, D, small a, B, C, D, providing those materials. The quantity of A, B, and C are 1,500, 1,800, and 900 kilograms respectively. The suppliers of A, B, C, and D are 1,000, 800, 1,500, and 1,200 kilograms. Supplier D does not provide the material B. The material price are listed in the following table. Try to analyze under the small list material cost how the company carry out the procurement strategy. So this is the problem that for a specific material the company want to buy, and because different price and some company might be not provide a certain kind of material. So what is the minimum cost so that the company can buy the material to produce their products? Okay, so remember D, small d here, right? Okay, the supplier D, supplier D here does not provide material B. So the unit cost for material B comes from supplier. You can give a very big number, right? Remember that? So you can construct a table and use the mathematical model or northwest method or minimum cost method heuristic to solve the problem. Okay, this is the this lecture talk about the variations and how to deal with if some routes from the start point to the end point are forbidden. Okay, so see you in next lecture. Bye bye.